Hello, dear friends from BSc Part 3. We are learning .NET architecture where we have already seen about the introduction to .NET and the various components of .NET architecture. The .NET architecture diagram with every component we have already seen. We have seen the common language runtime, common type system, common language specification, as well as MSIL, that is Microsoft Intermediate Language. Let us discuss with the handling of CLR, how we can execute the code in CLR, that is Common Language Runtime. Here you can see the diagram of Common Language Runtime. The execution will be held as follows. See here the source code from any of the language like Visual Basic, maybe C#, maybe C++, maybe Java, or even JavaScript. We know that there are 61 languages which are compatible with .NET architecture. So any of the source code written from any of the language from these 61 languages, we can take this source code for compilation purpose. See, the compilation will be done after writing of source code. Then every language code will be compiled separately in the CLR, and in the next phase the managed code is developed where the intermediate language code, that is also called as assembly code, is developed after compilation of source code. Again to the next, this will be provided to the common language runtime where this whole code is compiled with JIT compiler. The JIT compiler, that is the just-in-time compiler, is a particularly a very important compiler where it is very fastly processes the source code and compiled assembly IL code into the native code. After compilation of JIT code, the native code is produced, and this native code is again provided to the operating system services. So the whole process from the source code to operating system services is shown in this figure. One of the very important component of .NET framework is framework base class library. The class library, which is a comprehensive object-oriented collection of reusable types. This class library can be used to develop applications which will include the traditional command line applications, the graphical user interface applications, applications based on the latest innovations provided by ASP.NET. So it contains two types of forms, that is web forms and XML web services. So this is the base class library where all the different type of codes, all the different types of built-in functions are written in base class library. So all these base class library functions which are actually residing in the base class library in the .NET framework architecture. In the figure itself, at the lower side, figure shows that the unified classes, that is the whole classes which can be compatible with other languages, and the web classes where the ASP.NET controls caching, security, session, configuration. All these classes are actually stored in the base class library. Even though those are actually connected to the ADO.NET, that is data where ActiveX data objects will be connected with the .NET framework, where ActiveX data objects, the SQL queries, also the type queries, all these will be stored and that can be processed with .NET Framework base class library. On the another side, the Windows Forms is designed and the component model is also designed. So this is about the base class library. The traditional command line applications also we can develop in the base class by using base class library and .NET framework. The framework class library, what it means that hierarchical class library that can be utilized across multiple language and platforms. So those framework class library contains reusable classes, interfaces, and components which can be used for developing components and web services, developing Windows Forms applications, developing web form applications, working with directory services, event logs, processes, message queues, and timers. This is also useful for creating and managing the threads. Also, we can manage the application security by using framework class library. What are the key features and benefits of framework class library? It is a cross-language interoperability. So we can interoperable the language. Many languages we can compatible with the .NET framework. It is consistent and unified programming model. It is object-oriented and extensible class library. What do we know about the architecture, which we have discussed many points like common type system, common language specification, common language runtime, and all many with the JIT compiler, MSIL, that is Microsoft Intermediate Language. With this all, we also specified to explain that architecture is also having the web services, so which is the top layer which provides .NET users with the web services for e-commerce and business-to-business applications. The framework and libraries having ASP.NET development environment where we can develop the smart web pages. ADO.NET, which is an XML based improvement for database and object relational processing. There is interchange standards. It is a platform independent means of exchanging objects. It is simple object access protocol. It is web services description language also. The architecture is containing the development environment where we can write our source code with the Visual Studio .NET in the language like C++, Visual Basic and Visual C Sharp, as well as Java, etc. There is a component model which is derived from original component based development, that is CORBA, J2EE, and component object model, that is COM. The .NET allows building assemblies which consist of a number of classes with well-defined interface. Now we have to get learning about the assemblies which the .NET allows. Building of these assemblies, it consists of number of classes. Then ideal absent in .NET. This is the overall structure of .NET framework which we have already seen earlier in our last many sessions. Even though we are just overview about this .NET framework, see here there are different layers. That the yellow colored layer which is having the ASP.NET and Windows Form we can develop at the outer part, where we can develop the web services and web forms, and those application services can be developed. In the Windows Form we can develop the controls, drawings, as well as Windows application services. It has another layer. We know that about the framework class library we have already seen, but even though there is an overview about this class library which contains many built-in functions and the ADO.NET XML, the threading will be done, IO operations will be done, the network also stored in class library, the security is provided, the diagnostic, everything is done, etc. Many things are done with the help of framework class library. And at the last, we know that common language runtime, which is a basic building block, as well as it is a heart of .NET framework. So it contains memory management, common type system, and the lifecycle monitoring. Also, we know that common language specification is also done with the common language runtime. Next, we know that we have already seen about the MSIL and JIT, that is just-in-time compilation. We know that we have provided source code from C# and it can be compiled into the MSIL, that is Microsoft Intermediate Language. This is similar to Java bytecode. The MSIL allows for runtime, type safety, and security, as well as portable execution platforms. All these things will be done in the Windows. Microsoft Intermediate Language code cannot play tricks with the pointers or illegal type conversions. So pointers we cannot do in the .NET. The MSIL architecture results in applications that run in one address space, thus much less operating system overhead. The compiler also produces metadata. What is this metadata? Metadata is a definition of each type in your code. It is a signature of each type of members that your code references, other runtime data for the common language runtime. So metadata along with the MSIL enables code to be self-describing. No need to separate type libraries, IDL or registry entries. So metadata is a particular file which specifies what is your code, in which language it is written, as well as what type of libraries are maintained with your code. When code is executed by CLR, a JIT compilation step occurs. The code is compiled method by method to native machine code. As we have already seen the actually how source code will be again converted to native code. See here the packaging as well as the modules, types, assemblies and the manifest. Here is the hierarchy of all these packaging. At the outer set there is the assembly, then manifest, then module, then metadata, and at the last that is MSIL, Microsoft Intermediate Language. We know that what is this assembly. As we can see about this assembly, a Microsoft .NET assembly is a logical unit of code which contains codes that the common language runtime executes. Assembly is really a collection of types and resource information that are built to work together and form a logical unit of functionality. During the compile time, metadata is created with Microsoft Intermediate Language and stored in a file called a manifest. So second is a manifest. We know that when metadata is created, manifest also stored in the MSIL. So both metadata and Microsoft Intermediate Language MSIL together are wrapped into portable executable, that is PE file. Manifest contains information about itself. This information is called assembly manifest, which contains information about the members, types, references, and all the other data which runtime needs to execution. So every assembly you create contains one or more program files and a manifest. There are two types of program files, that is process assemblies and library assemblies. Each assembly can have only one entry point. So we can create two types of assemblies, that is private assembly and shared assembly. A private assembly is used only by single application and it is usually stored in that application's install directory. A shared assembly is one that can be referenced by more than one application. So if multiple applications need to access an assembly, we should add the assembly to the global assembly cache. So this is about the assembly, manifest and metadata. Here you can see a module which refers to a binary such as an .exe or DLL. So module refers to a binary file which is a .exe or .dll. The modules contains definition of types such as classes, interfaces, structures and enumerations. An assembly contains a manifest, which is a catalog of component metadata containing assembly name, version, assembly file list, all files contained in the assembly, type references, which is mapped the managed types included in the assembly with the files that contain them, the scope, which is a private or share, and referenced assemblies. So no MSIL code can be executed unless there is a manifest associated with it. So assembly and manifest with the help of metadata file will be created while creating the source code as well as application. Packaging contains the modules, types, assemblies, and manifest. An assembly can be defined as one or more modules that can be up a unit of functionality. Assemblies can also contain other files that make up an application, such as bitmaps and resource files. So what is this assembly? This is a very important point with the point of view of your study, that assembly, which is defined as one or more modules which can make up unit of functionality. The assemblies can also contains other files that make up an application, such as bitmap and source files. An assembly is not any physical file. An assembly is a fundamental unit of deployment, version control, activation scoping, and security permissions. So there are two types of assemblies. First is a private and second is a shared. Private assembly, which is usually deployed in the same directory as the client application and used only by single application, and shared assembly, which is used by any application and used installed in a special global assembly cache. This is the .NET component model, which offers developers an component model directly based on object-oriented. It removes distinction between a program element and software component. Thus, it provides significant benefits over technologies like CORBA and COM. .NET get rid that ideal. We can use a .NET assembly directly as a component. So it uses interface documentation already present in the source code. The compilers for .NET supported languages retain this information as metadata as well as the self-documented components. The metadata is also available in XML format. Any application where it is a part of .NET or not contain obtain information about component. Thank you. Thank you very much.